on the periphery of the solar system, there is a little world bound by toxic ice lurking amid the great abyss of space. A giant shadow covering the stars from sight is unmovable over its rugged horizon, and the dim sun slowly traverses the sky. The sun rays here are not able to dissipate the semi-darkness of the frozen plain wrinkled with bottomless crevices, perpetually shrouded in shadow. This is Pluto, a lifeless kingdom of rock and ice covered by perpetual shadow. Let's find out more about it. Pluto is about 40 astronomical units away from the Sun, and is a dark and indistinguishable object. This distant celestial body follows a rather elongated orbit around the center of the solar system, completing it every 248 Earth years. We know that Pluto's radius is 1,188 kilometers, which means that it is noticeably inferior in size not only to all the planets of the solar system, but also to some of their satellites, including the Moon. At the same time, observations of the celestial body's proper motion made it possible to calculate its mass with a high degree of accuracy. It turned out to be small, only 1.3 times 10 to the power of 22 kilograms, or 1/8 of the lunar mass. It is easy to see that Pluto is much more similar to small celestial bodies such as Eris, Ceres, or Sedna in terms of its characteristics. This is the reason why it topped the list of dwarf planets in 2006. Due to its long and elongated trajectory, Pluto has a long orbital cycle. Only in 1989 did the planetoid first pass its orbit perihelion since its discovery, approaching the Sun as close as 29.7 astronomical units. Since then, this distance has been continuously increasing and will reach its greatest value in the year 2113. By that time, the dwarf planet will be near its aphelion, which is 49.3 astronomical units away from the center of our system. Thus, Pluto is a very distant and dim space object. That is the reason why it cannot be seen from Earth with the naked eye, and even in images from the Hubble Space Telescope, the dwarf planet looks like a murky brown disk without any surface details. Of course, in such conditions, it is almost impossible to study the celestial body properly. To solve this problem, the New Horizons unmanned orbital station was sent to Pluto in 2006. It took a long 9.5 years to reach its destination. On its way, it beamed back to us detailed images of Jupiter. It wasn't until 2015 that the spacecraft finally reached the main object of its mission. As it flew past Pluto, the station made about 400 observations, collecting more than 6 gigabytes of information, and it took more than a year to transmit this large amount of data to Earth. Unfortunately, the probe's trajectory did not allow photographing the entire surface of the dwarf planet. The fact is that New Horizons did not enter into an orbit around Pluto, but circled around it in order to be able to explore other space objects. Before moving on to the celestial body's terrain features, we need to understand its internal structure. According to the currently accepted model, Pluto has a massive core with a diameter of about 1,700 kilometers, consisting of a mixture of various forms of water, ice, and rocks in its center. It is surrounded by a 300-kilometer ice mantle. There are probably tectonic processes running in the mantle, and at the moment, they are quite understudied. The mantle, in turn, is covered by a crust which is a mixture of crystallized gases such as nitrogen, methane, and carbon monoxide. According to some assumptions, Pluto's core may generate enough heat to melt some of the icy mantle. In this case, deep beneath the surface of the planetoid, there should be a very salty and toxic ocean containing large amounts of dissolved ammonia. As for the surface temperature of the dwarf planet, it is very low and does not rise above 60 Kelvin, or 213 degrees Celsius below zero. Our journey around Pluto will start at the most outstanding and well-studied feature of its relief, Tombaugh Regio. This vast area is located in the equatorial zone of the planetoid and is shaped like a heart. This resemblance earned the region its informal nickname, Jeu the Heart. Its size reaches 2,300 kilometers, which means that the plane occupies about a quarter of the celestial body's entire area. Tombaugh Regio's surface is not homogeneous. Thus, there is a smooth and light plane in its western part known as Sputnik Planitia, whose diameter measures 1,492 kilometers. An elevation map will reveal this region to be a vast lowland area. It is covered with a thick layer of nitrogen ice, as well as carbon monoxide and solid methane. These substances have a light coloring, which makes some parts of the plain reflect up to 90% of the light falling on them. There are also virtually no craters, which means that the region is very young in geological terms. According to the main hypothesis, Sputnik Planitia formed about 100 million years ago when Pluto experienced a collision with a large celestial body. As a result, a huge impact crater appeared and was filled with contents of the hypothetical inner ocean of the dwarf planet, which rapidly froze. Some typical features of the relief of the plain can serve as evidence of this. For example, there are quite a number of smooth surface areas on it, ranging from 20 to 30 kilometers in size, with hills and depressions concentrated on the borders between them. This kind of structure resembles convection cells, which appear in any fluid heated from below. This may serve as an indirect confirmation of the hypothesis of Pluto's warm interior. Tombo Regio is surrounded by comparatively high mountain ridges. Thus, Hillary Montes, lying to the west from Sputnik Planitia, reach 3.5 kilometers in height. Tenzing Montes are located in the southern part of the heart. Some of them tower as high as over 6 kilometers above the dwarf planet's average surface level, which makes this ridge the tallest one found on Pluto. Remarkably, these rocks are likely to be made up mostly of water ice, and in temperatures as low as here on Pluto, water ice is as solid as rock. Moving a little further south, we can see a deep basin surrounded by massive multilayered ridges of ice and rock. It is assumed that it may be the vent of an ancient cryovolcano, and the rock around it is its numerous frozen eruptions. Their chemical composition is of great interest to science because once it is known, the peculiarities of Pluto's inner makeup may be studied. The eastern part of Tombo Regio is darker. In addition, its surface is pockmarked with a great number of craters, which means that this region is by far older than Sputnik Planitia. Moving further east along the equator, we will see a chain of dark spots hundreds of kilometers in diameter. These objects are called maculae and are named after dark deities of various cultures. For example, one of them is named Balrog. Together, they form a giant structure called the brass knuckles, encompassing the celestial body along the equator. The maculae are separated by high mountain ranges, and their surface is cut by deep crevices reaching hundreds of kilometers in length. Cthulhu Macula stretches to the west from Tombo Regio. It is the largest dark spot on Pluto, measuring almost 3,000 kilometers. Its surface reflects no more than 30% of the light shed on it, which is a stark contrast with the bright and light Sputnik Planitia close by. There is still no reliable information about what maculae are. It is assumed that their dark color is due to a high content of tholins, combined with a relatively large concentration of impact craters. This indicates that maculae are remarkably old. It is also known that the surface of Cthulhu Macula is heterogeneous. Thus, its relief in the western part is undulating, the central part is a smooth plain, and the eastern part is covered with mountains and craters. With the dark spot of Cthulhu Macula behind us, let's head north. Here lies Lowell Regio, the vast valley surrounding Pluto's North Pole. Surprisingly, it is this place that is currently the most illuminated part of the celestial body's surface. The point is that Pluto's axis of rotation has a very large tilt with respect to the plane of its orbit. So in its movement, it found itself facing the Sun with its north pole. It is assumed that it is for this reason that the density of Pluto's atmosphere has tripled over the past 30 years despite the growing distance from the Sun. It is likely that the Sun's rays evaporate nitrogen ice settled at the pole, which goes into the dwarf planet's atmosphere. In its orbital motion, Pluto has a number of peculiarities compared to the planets of the solar system. In addition to the fact that its orbit has a noticeable tilt to the ecliptic plane, the planetoid itself constantly performs cyclic oscillations near a certain point. This is due to the presence of a large satellite gravitationally affecting the dwarf planet. It is called Charon, and its mass is 1.52 times 10 to the power of 21 kilograms, which is more than 11% of the mass of Pluto itself. As a consequence, Both celestial bodies orbit a common mass center between them. They are tidally locked to each other, so they face each other with the same sides at all times. Unlike Pluto's, the surface of its satellite is noticeably darker and shows an abundance of water ice, which is mixed with methane and nitrogen only in some regions. In addition to Charon, there are several other satellites, but all of them are much smaller and irregular in shape. Nix and Hydra, discovered in 2005, measure several tens of kilometers, and Kerberos and Styx, which were discovered later, are not over 16 kilometers in diameter. All of these celestial bodies consist mainly of water ice and were probably captured by Pluto's gravity from the Kuiper belt. Unfortunately, a significant part of Charon was not caught in the field of view of the New Horizons probe's cameras, but many curious terrain features can be found on the visible surface of the celestial body. For example, to the south of the equator lies a vast region called Vulcan Planum. Its area is not known precisely, but it is not less than 400,000 square kilometers, which is comparable with the size of an average European country. Here, the highest summit of Charon can be found, Kubrick Mons. Its diameter measures around 40 kilometers, and according to some estimates, its height reaches 4,000 meters. In addition, the mountain is surrounded by a wide circular moat up to 2 kilometers deep. According to some assumptions, Kubrick Mons may in fact be a cryovolcano. In this case, it is very likely that the area around it has sunk under its own weight due to the emptying of the underground reservoir. To the north stretches the vast Ozterra, the surface of which is pockmarked with many craters. It is separated from Vulcan Planum by a system of giant ledges and crevices with a total height of about a kilometer. The largest of them is Serenity Chasma, which is 200 kilometers long, with a width varying from 40 to 50 kilometers. It can be as deep as 7 kilometers, and it is difficult to explore its bottom because of the thick shadows cast by the steep slopes. Further north, near the very pole, there is the giant Mordor Macula. Its diameter reaches 475 kilometers, and its origin is still debatable. According to the dominant hypothesis today, nitrogen and methane floating from Pluto's atmosphere were trapped by Charon's gravity and so settled at its poles. After exposure to ultraviolet radiation, they turned into tholins and gradually concentrated in the ice of the celestial body. This assumption needs verification, which will be an object of future missions. Charon largely remains a mystery to us because its research is only just starting. Although the Pluto-Charon system is undoubtedly one of the most interesting structures in the solar system, it is still understudied. Unfortunately, the New Horizons probe left its environs long ago, and the celestial bodies themselves are rapidly moving away from us, taking their secrets along. At the moment, the probe is more than 50 astronomical units away from the Earth and from time to time beams back to us some extremely important data. By about 2030, all of its systems will eventually fail, and the probe will be left all alone in the chilling recesses of space.